The James Webb Space Telescope, JWST, has spotted something cool. Light beams shooting out from a city way out in space. This has gotten everyone talking about aliens again. The telescope zoomed in on Proxima Centauri b, the closest exoplanet we know about, and saw weird, strong light flashes. Could these lights mean there's an alien civilization with tech? We'll see what happens. People have been wondering about alien life for ages. Whenever we find a hint, everyone gets excited. The JWST just took a big step by finding clues that life might be out there while looking at the huge areas of space. This awesome telescope saw something amazing on a faraway planet, lights like city lights, which suggests there might be a city on that planet. This discovery is making scientists really excited. Could be the breakthrough we've been waiting for, hinting that smart beings are building societies in ways we're just starting to get. NASA scientists are blown away that these city-like lights are coming from 4 light-years away. They're wondering how long these signals have been floating around, waiting for us to have the tech to see them. David Kipping, a scientist at Columbia University, said that the planet with these lights is super weird. Most rocky planets soak up sunlight and spit it back out as infrared energy, but this exoplanet acts differently because of how it interacts with its star, Proxima Centauri. This shows how important the JWST is. You can see infrared light, which was key to spotting Proxima Centauri b's strange features that are needed to figure out what its atmosphere is like. Scientists are going to keep using the telescope to really check out this planet's atmosphere and see if life could live there. The JWST is awesome at picking up infrared radiation, so it can see what's happening on Proxima Centauri b even at nighttime. Most telescopes can't see faint signals in space, but the JWST can spot even the smallest glows. This helps confirm if those city lights on Proxima b's dark side are real. The telescope can pick up artificial light in space if it's in a specific frequency, which is narrower than the light from stars. Proxima Centauri b interacts a lot with its sun, which really affects its surroundings. Like other planets, it soaks up tons of energy from Proxima Centauri. As it goes around its star, it has day and night like Earth. The planet gets super hot during the day and colder at night. The temperature range on Proxima Centauri b depends on its structure. For example, if the planet has an atmosphere, the difference between the hot and cold sides would be huge, burning hot on one side and freezing on the other. This big temperature difference is really interesting to astronomers because it tells them a lot about the planet's atmosphere. Because the JWST can see infrared light, it can study heat coming from the planet, giving us clues about its climate. The JWST orbits Earth in sync with Proxima Centauri b's 11.2 Earth-day orbit, so we can really study how it interacts with sunlight. If Proxima Centauri b has an atmosphere, the next step is to check what it's made of to see if it's good for life. Spotting stuff like oxygen, water vapor, and methane would mean the planet might support life. This means studying starlight as it passes through the planet's atmosphere, which is pretty complicated. Even though the JWST is great at studying exoplanet atmospheres, it wasn't only built for that. It's good at measuring water vapor, carbon dioxide, and methane, but not as good at spotting free oxygen, which is a big sign of life. But it can still spot ozone, which is a good sign of a stable atmosphere that could support life. As astronomers look at the JWST's data, we're getting closer to figuring out if we're alone in the universe. Keep in mind that the JWST can only study a few nearby exoplanets. To learn more about alien atmospheres, scientists are using ground-based observatories like the Extremely Large Telescope (ELT), which should be up and running in 2027. The ELT will give us a better look at the atmospheres of faraway planets, giving us more accurate data about if they could support life. Scientists can't wait for new space telescopes like the ELT. In the meantime, the JWST is still important for checking out remote planetary systems. Even though it has limits, it keeps finding cool stuff that could change what we know about what's out there. Experts have big plans for future observatories. They wanted tools that block starlight so they can see planets better, like using your hand to block the sun. These advanced telescopes will focus on the dim light from exoplanets, which will make it easier to study their atmospheres and see if they can support life. But it's still hard. Stars are super bright and drown out the light bouncing off their planets. This makes it tough to study planetary reflections, which is how we figure out their features. To fix this, scientists are building new tech. One thing is a coronagraph, which is put inside a telescope and blocks starlight but lets planet light through by changing how light waves work. Coronagraphs make stars less bright so we can see planets better. Another cool thing is the star shade, a huge petal-shaped spacecraft that flies with a telescope miles away. The star shade stops starlight from entering the telescope, so only planet light reaches the sensor. This is really helpful for seeing planets in the Goldilocks zone, where conditions might be right for water and life. But these advanced tools have to be super precise. For example, the star shade needs to be perfectly aligned within millimeters over huge distances. Space missions also have challenges, like needing to shrink tech, save energy, and survive tough environments. Even with these challenges, the rewards could be huge. If we can accurately see and understand exoplanet atmospheres, we might find biosignatures, chemical signs of life like oxygen, methane, or water in the right amounts. These chemicals could mean there are biological processes happening, which points to life beyond Earth. Scientists are also trying to directly capture detailed photos of faraway planets. Future telescopes might have adaptive optics, which fix image problems caused by Earth's atmosphere or telescope motion, so we get sharper images. With starlight blocking tech, these improvements might let us not only see exoplanets, but also map their surfaces and study their weather. Building new space telescopes is a big step forward in trying to answer a basic question. Are we alone? By getting better at studying faraway planets, we're getting closer to finding out if life exists outside our world, which could change how we see the universe. Space science and the search for alien life are speeding up as scientists go further into space. The JWST is leading a new time of astronomical discoveries. The data it's collecting is helping astronomers make historic findings about the structure, chemistry, and if exoplanets can support life. Each new discovery adds another piece to the puzzle, helping us understand if life is out there. Finding Proxima Centauri b could be the start of a big change in how we study alien life. Proxima Centauri is our closest star system, so scientists have been studying it for years. But real proof of life, like artificial light or signs of advanced infrastructure, was just a theory until now. The JWST might have found such light, which makes us hopeful that maybe we'll contact other intelligent species someday. This kind of discovery excites scientists and the public, inspiring people to dream beyond our planet. As the JWST keeps scanning the stars, it's not just looking for artificial lights, but also studying planetary atmospheres, their gases, and if those gases can support life. Searching for biosignatures like methane or carbon dioxide in the right amounts is important for seeing if these planets are good for life. The JWST can study these things in ways that past instruments could not, showing us that other Earth-like planets might be out there. What's cool about Proxima Centauri b is that it's in the habitable zone of its sun, where temperatures could allow water to be liquid. This zone, called the Goldilocks zone, is just right for life as we know it. Besides finding planets that could support life, future telescopes will also study how exoplanets and their stars interact. Some planets, like Proxima Centauri b, are tidally locked, so one side always faces the star and the other side is always dark. This can cause big climate differences across the planet and affect if it can support life. Understanding these things is important for figuring out if planets are habitable. Making tools that block starlight, like coronagraphs and star shades, is a big deal in astronomy tech. These instruments block the bright light from stars, so we can study the dim light that reflects off planets. That dim light can tell us about a planet's atmosphere, surface, and if it can support life. A cool thing is direct exoplanet imaging. Using adaptive optics and light-blocking tools, astronomers hope to take high-resolution pictures of faraway worlds. These pictures might show planetary features, oceans, landforms, or even weather, giving us a look into alien environments. These things could really help us understand where and how life might exist beyond Earth. As we explore the universe, the James Webb Space Telescope and future missions are becoming super important. Its skill at spotting faint energy, studying atmospheres, and finding chemical signs of life is changing space science. With every tech improvement, we're getting closer to discoveries that could change how we see everything. Space science and astrobiology are changing fast, opening doors to things we never thought possible. Scientists are going deeper into the unknown, and the JWST is at the front of this exciting new chapter. The data it's collecting is already helping scientists reach new conclusions about the structure and life-supporting potential of faraway worlds. With every new thing we learn, we get closer to answering one of the biggest questions ever.